Assalamualaikum warahmatullahi wabarakatuh and good day. So in previous video, you have learned definition 7.2, whereas when you have one random variable come from standard normal distribution and then another random variable come from chi-square distribution, when you have combine these two and then you have the new function of it, you will give you a t distribution. Okay, so in this definition 7.3, okay, you have let W1 and W2 be independent chi-square distributed random variable with nu1 and nu2, okay, degree of freedom. Then when you divide these two random variables, okay, you will get F distribution. Okay, so this F distribution is with nu1 numerator degrees of freedom here and nu2 is denominator degree of freedom. So if you remember in previous video, I've mentioned this one a little bit. Okay, when you have two population, okay, and then one population is come from standard normal, which is you have one mu and sigma square, and then the sigma square is unknown, so you will use s square, isn't it? So this s square can be used to estimate sigma 1 square. So if we combine these two random variable, okay, so that's mean for population 1, sigma 1 square, for population 2, sigma 2 square. So when we divide these two, you will get F distribution. So that's why here you can see that W1 is come from chi-square distribution random variable, okay, because you can see that when we have one population variance, it will give you chi-square distribution with n minus 1 degree of freedom. So when we have this and you divide, you will get F distribution. Okay, so if you can see here that if F possesses an F distribution with nu numerator and nu2 denominator, degree of freedom, then expected F can be this one, nu2 divided by nu2 minus 2 if nu2 greater than 2. And also, if nu2 greater than 4, then your variance of F will give you this one. Okay, so here, expected F, expected variance F, okay, this one all from previous theorem knowledge, okay, but we just use it when we have this kind of different equation like this. Okay, so notice that the mean of F distribution random variable depends only on the number of denominator degree of freedom nu2. Okay, here, and then you consider once again you have two independent random variable, okay, random sample from normal distribution. Okay, this is related with previous video in this chapter. Okay, so we know that this W1 will give you n minus 1 time minus 1 that times with s square divided by sigma 1 square. And then W2 is for n2 and s2 sigma 2 lah. And then here you can see that you have W1 follow chi-square distribution with nu1 degree of freedom. W2 follow chi-square distribution with nu2 degree of freedom. Okay, thus definition 7.3 will give you this one. All right, so you can see that, okay, this is in term of W1 and W2. And then this one actually is come from previous video. You know that W1 is follow chi-square distribution function with n minus 1 degree of freedom. So if you have 2, so you have 1 divided by 2, you have this equation. All right, so here it become, when you cancel out everything, it become like this. So this one actually, you will get F degree of freedom with n1 minus 1 numerator degree of freedom, which is here, and then n2 minus 1 denominator degree of freedom, this one. And if you remember in applied statistic, you've used this one, isn't it? You just use the formula to apply. But here in this class, you learn how you get that one. All right, so look at example 7.7, page 363. Okay, so consider if we take independent sample of size n1 equal to 6 and then n2 equal to 10 from two normal population with equal population variance. Finds the number B such that this one. So you can see here, this is what you've done before in applied statistic. Okay, so how to solve this one? Use statistical table and formula. All right, so now you know your n1 is 6, n2 is 10. So by using the formula here, you can see that the population variance are equal. So when it's equal, okay, you can cancel it out. Actually, this one you can cancel it out, isn't it? This one actually had S1 square divided by sigma 1 square times sigma 2 square divided by S2 square. So since it's similar, so you can cancel it out. So you will get this one. All right. And then remember for S1, you can see 6 minus 1 is 5 degree of freedom. And this one you will have 10 minus 1 is 9 degree of freedom. All right. So now you want to find this one. Okay. Since less than beta, you can also do like this. 1 minus probability S1 square divided by S2 square greater than B. All right. This is F distribution, isn't it? F distribution. So when you have F distribution similar, you will have skewed to the right. All right. So here we want to find number of B. Okay, cutting off an upper tail area of 0.05 under the F density function with 5 numerator degree of freedom and 9 denominator degree of freedom. All right. So in this case, actually, you have 0.95. Okay, so you know that your alpha is what? 0.05. So in this case, instead of less than, which is the left side here, you can find the right side here. So you just 1 minus this side. Easier, isn't it? So here will be 0.05. No need to divide by 2 because they want just one side. Okay, but you must understand this one because you didn't find the left side because the given value in the table is the right side. That's why you use 1 minus something. Okay, so now if you look statistical table formula from your applied statistic class, okay, it will be page 37. Okay, page 37. Okay, so look here, 5, 9. Okay, 5, 9. And then you look here is 0.05. So you find 0.05 first. So if you look, it will be at page, let me see, page, yeah, page 51. Okay, for 0.05, page 51. So look, 5, 9. Okay, so 5, 9, it gives you 3.4817. 3.4817. Okay, this one just 2 decimal places. So you can use 4 decimal places as well. So you can see that you will have 3.4817. So that's how you use it. Okay, but here most important is how do you understand, okay, from these two random variable, which is one from chi-square distribution with n minus 1 degree of freedom, and the other one is also one random variable which is come from chi-square distribution n minus 1 degree of freedom. When you divide these two, you get F distribution. That's the most important you must know. Okay, this one actually you have done, this example actually you have done before in applied statistics. Okay, so even when the population variance are equal, the probability that the ratio of the sample variance exceed 3.48 is still 0.05. Okay, assuming that the sample size will be this one. So here actually you can see that you will have the B is 3.48 lah. All right, but you can find the the value, okay, here. All right, so you can see that when you have alpha 0.05, it become 3.4817. So here you will have that. All right. Okay, so now this is exercise. Okay, you can try your own, page 307. Okay, try do, very important. Okay, look, do you understand or not this chapter? Okay, this is not the end of the chapter yet. Okay, but this is just one subtopic. Okay, which is sampling distribution. And if you look the content here, it's about sampling distribution related to normal distribution. This one, we only discuss this one. 5, 6 videos ni, we only discuss about 5.1. Okay, because you must understand from normal distribution, it can be chi-square distribution, it can be T distribution, okay, it can be F distribution. So that's very important. Okay, you must understand how it's become chi-square, how it's become T distribution, and how it become F distribution. Okay, and the proving is also very important lah. Okay, so you can try exercise. Okay, you can try look exercise. And then if you have any question, okay, for sure you can ask me. All right. Thank you, class.